start our physics syllabus. Here first we will start the first topic, units and measurement. This is the first topic, units and measurement. In physics, chemistry, or in all sciences, there is need of measurement. In all science subject, there is need of measurement. That means we have to measure different things in our day-to-day life. We have to measure size of object. We have to measure volume of liquid. We have to measure duration, that is time. We have to measure length or area, or we consider different things. That is, we have to measure electric current, then potential difference, or we have to measure magnetic field. We have to measure gravitational field, and number of more things we have to measure. And for measurement, we have to use different systems of units. That means how these all things can be measured. This is the need of our day-to-day life. Now, for measurement, we consider there are different systems of units. Here we consider systems of units. We will see one by one. First system we consider CGS system. Secondly, we consider MKS system. Third, we consider FPS system. And fourth one, we consider SI system. Now we will see what is meant by CGS system. Here you see, CGS system means we consider centimeter, gram, second. MKS we consider meter, kilogram, second. FPS, foot, pound, second. And here is SI, we consider here long form of this SI, that is System International. That is internationally accepted system, which is very near to this MK system. These all are the systems of unit. That means length is measured in centimeter, mass is measured in gram, time is measured in second. Here length is measured in meter, mass is measured in kilogram, time is measured in second. Here length is measured in foot, mass is measured in pound, and time is measured in second. And this system international, it is very close to the MKS system. All these are the four systems of units. Now we consider here next thing, fundamental quantities and its units. Fundamental quantities and units. See here. First we will define what is meant by fundamental quantity. fundamental quantity. Here the physical quantity which do not depend on any other physical quantities for their measurement are called as fundamental quantities. See here, this is the definition of fundamental quantity. The physical quantity which do not depend on any other physical quantities for their measurement are called fundamental quantity. That means this type of physical quantities, they doesn't depend on any other physical quantity. Here we consider there are seven fundamental quantities. That is, we can write here length, mass, time, temperature, electric intensity, electric current. We consider here electric current, then luminous intensity, and amount of substance. See here, there are seven fundamental quantities. That is, we consider here length, mass, time, then temperature, electric current, luminous intensity, and amount of substance. These are called as seven fundamental quantities. Now here we consider next thing, that is fundamental units. The units used to measure fundamental quantities are called fundamental units. Here the units used to measure the fundamental quantities are called fundamental units. Now you see here we have considered seven physical quantities: length, mass, time, temperature, electric current, luminous intensity, and amount of substance. Now we will see what are its units. See here, suppose we consider a table. Suppose we consider this is the table. Here we consider fundamental quantity. Here we consider SI units, and here we consider symbol. We can just suppose this is the table. We will see one by one. See here. First fundamental quantity, that is length. The unit of length we consider in MKS or SI system, it is meter and its symbol is m, small m. Second one, mass. Then unit is kilogram and symbol we consider here kg with the symbol. Third quantity we consider time. Then its unit is second and we write simply s. Fourth fundamental quantity, we consider temperature. Temperature, it is measured in Kelvin and we consider symbol K. Fifth fundamental quantity we consider here electric current. Unit is ampere. We consider symbol A. Sixth fundamental quantity we consider here luminous intensity. Luminous intensity measured in candela. Symbol is CD. And last physical quantity, amount of substance. Amount of substance. It is measured in mole and symbol we write here mole. These are 7 physical quantities. You understand this. That is, we consider here length, mass, time, temperature, electric current, luminous intensity and amount of substance. Here you see length. Length is measured in MK for SI system, that is meter. Symbol is M. Mass, SI unit is kilogram. Symbol is kg. Time, SI unit is second. Symbol is S. Temperature, then it is measured in Kelvin. Symbol is K. Electric current measured in ampere. Symbol is A. Luminous intensity, intensity of light, luminous intensity, it is measured in candela. Symbol is CD. And amount of substance measured in mole. Symbol is mole, MOL. These are all about fundamental quantities and fundamental units, and its units we consider here this table. Now we consider the next article. Derived quantities. Derived quantities. The physical quantities. The physical quantities which depends on other physical quantities, for their measurement are called as derived quantities. This is the definition. Derived quantity means the physical quantity which depends on other physical quantities for their measurement are called derived quantities. There are many more derived quantities. We consider, suppose, for example, we consider here force, pressure, volume, area, etc. All these are the physical, that is derived quantities. Now we will see next definition, derived units. Definition is same like fundamental units. That is the units used to measure derived quantities are called as derived units. See here, the units used to measure derived quantities are called as derived units. Now we consider here, suppose for example, we will see examples first. Suppose we consider here velocity. Then velocity is equal to, displacement upon time. Now we consider here unit of velocity. We can write here same thing, unit of displacement upon unit of time. Therefore, unit of velocity is equal to unit of displacement. We consider here meter, and unit of time is second, meter per second, or we can write like this, meter second raised to minus 1. This is the unit. That means velocity is the derived quantity which depends on displacement and time. Displacement is fundamental quantity, time is also fundamental quantity. Then unit of velocity is equal to unit of displacement upon unit of time. Therefore, unit of velocity is equal to meter per second, or we can write meter second raised to minus 1. Now we consider next example. Suppose we consider acceleration. Acceleration means we can write here, that is acceleration is rate of change of velocity. I will write like this, change in velocity with respect to time, or change in velocity divided by time. I will write like this. And therefore, unit of acceleration is equal to unit of velocity divided by unit of time, which is equal to, I will write here unit of velocity, that is meter per second, and per second unit of time, or I can write here meter per second square, or ms raised to minus 2. This acceleration is also derived quantity because it derived from change in velocity divided by time. Again, velocity also derived quantity, that is displacement upon time, and in this way unit of acceleration is found out, and this unit also we call it as a derived unit. This unit we call it also as a derived unit. Then third we consider example. Suppose force is equal to, that is mass into acceleration, F is equal to ma. Then unit of force is equal to unit of mass into unit of acceleration. Unit of mass, suppose I will write here kg, and unit of acceleration is meter per second square. Therefore, I will write here kg meter second raised to minus 2. This is the unit of force, and we call it also as a Newton. 1 Newton, this is the unit of, or Newton is the unit of force. Symbolically can be written like this, Newton. We consider fourth example, work or energy. It is nothing but force into displacement. Okay, work is equal to force into displacement. Again, unit of force we consider here, suppose Newton is the unit of force, I will write here unit of work is equal to Newton, and displacement is measured in meter, Newton meter. We consider here which is equal to, also we can write here Newton meter, we consider it is also a joules, and symbol is, I will write here J be the symbol of this work, unit of work or energy, joule. This is mks. Also arc also is the unit. Now we consider again one example. Suppose velocity gradient. I will write dv by dx. See here, rate of change of velocity with respect to displacement. Change in velocity by displacement. Then velocity is measured in like this, meter per second. I will write here unit of velocity gradient, meter per second, and this is also meter. This meter gets cancelled, means we get per second or second raised to minus 1. This is the unit of velocity gradient. And you see here all these, that is velocity, acceleration, force, work or energy, velocity gradient, all these are the derived quantities, and we have derived the units of derived quantities from the units of fundamental quantities. Here displacement, time, again here velocity means displacement per unit time, again time, then mass is the fundamental quantity, acceleration means rate of change of velocity, we have derived m meter second raised to -2 we have put here. That means we have derived all these units. Many more units are there. That means we are going to see or study all this physics. In this you get different physical quantities in section 1, also in section 2. Then we can derive the units of all that physical quantities by the same way. I hope you all understand this. Now we consider here, these are the derived quantities and derived units. We consider here 2 supplementary units. That means we have, up till now we have studied fundamental units, fundamental or derived units. We consider here supplementary units. 2 supplementary units. There are 2 supplementary units. 2 supplementary units. You know that is there are 7 fundamental quantities, and we consider here 2 supplementary quantities. That is, we consider here plane angle, and we consider next quantity, we consider solid angle. This plane angle, it is measured in radians, and we consider solid angle, it is measured in steradian. This is denoted by, we consider here d theta, and this is denoted by, we consider d omega. These are the 2 supplementary units. I hope you all understand this. This is our first period. In this period we have studied, that is what is meant by units, what is the need of units, then we consider system of units, then we have seen that is fundamental quantities, its definition, then 7 fundamental quantities, then fundamental units with its symbols, then derived quantities, number of derived quantities are there. We have seen unit definition of derived units. We have derived some derived units from their formula. We have seen these supplementary quantities or supplementary units, that is plane angle measured in radians, solid angle measured in steradian. I hope you all understand this. Thank you.